This lesson is on systems of linear equations in two variables. It is section 1.5. The essential question for this lesson is, how do you solve systems of equations in two variables? Now let's start off by thinking of the intersection of two streets, okay? We have two streets that intersect, and there is a common region to both where they intersect, okay? So you might think of this in mathematical terms by going to a graph where you have two lines that intersect. Now, if you think of a graph, and we think of two lines on a graph that intersect, we might have something that looks like this. Okay? And this region here where they intersect is common to both lines, so therefore you can think of that as being a solution to both lines. Well, two lines on a graph don't always intersect. We might have two lines that are parallel, in which case they never intersect. And lastly, we might have a situation where we have two lines that are on top of each other. Okay? So these are the three cases we could have. We could have two lines that intersect, two lines that are parallel, or two lines that are one on top of the other. In all cases, however, we have two equations or a system of equations, or in the cases we're talking about here, a system of linear equations. So let's look at an example here. So let's say I have two equations. One of them is x plus y equals 5, and the other is 2x minus y equals 4. Now, I want to find the solution set that satisfies both of these equations. Well, one way I could do it is to take and graph each of these equations. So if I graph each of these, I've got x plus y equals 5 is the blue line, and 2x minus y equals 4 is the red line, notice that they do intersect, and this is freehand, so it doesn't give me the exact value here, but if we were to do this exactly, we would find that these would intersect at the point 3, 2. So x equals 3, y equals 2 would be a solution for both of these equations, or it's the solution of the system of equations. It's where they intersect. Now, there are other ways that I could take and solve the system of equations. One of them is called solving a system by elimination. So if I take the first two equations again, and if you look closely at these two equations, you notice one thing. If I were to add these two equations together, which I can certainly do since that we're adding things that are equal, if I add the left side of the equal sign and add the right side of the equal sign, notice what happens. The y cancels out, and we're left with only x. So when we add these two together, what do we end up getting? Well, x plus 2x is 3x, plus y minus y is 0, and 5 plus 4 equals 9. So I've got 3x equals 9, or x simply equals 3. Well, once I know what x is equal to, I can plug it back in one of the above equations and figure out what y is equal to. Now I'm going to use the first equation because it's a little easier. So I plug in 3 for x, and I've got 3 plus y equals 5, or simply y is equal to 2. So notice I've got x equals 3, y equals 2, which is the same value we got when we graphed the two equations. So this is known as solving a system by elimination. So we have solving by graphing, which is obvious. Now we could also do this by solving by elimination. Well, there's one other method that we could use, and this is referred to as solving by substitution. So let's start again with the same two equations we had before. So I've got the same as we had before, x plus y equals 5 and 2x minus y equals 4. Now, when we're solving by substitution, we take one of the equations and solve it for one of the variables. Okay, so again, I'm going to start with the first equation, x plus y equals 5, and I'm going to solve it for y. So again, if I take the x plus y equals 5 and solve it for y, I end up with y is equal to 5 minus x. Now, I take y equals 5 minus x, and I substitute that in for y in the second equation. So now I have 2x minus, parentheses, 5 minus x equals 4. Well, if I solve this for x, so getting rid of the parentheses, this gives me 2x minus 5 plus x equals 4, which initially gives me 3x minus 5 equals 4, which in turn gives me 3x equals 9, and finally x is equal to 3. Now if I take x equals 3 and go back up here to this y equals 5 minus x, so substituting 3 for x, we get y is equal to 5 minus 3, or simply y is equal to 2. So again, this is solving by substitution. We end up with the same answer. The solution for this system is x equals 3, y equals 2. Now just to review, when we have a system of linear equations, we have 3 ways we can solve them. We can graph them to find the intersection. We can solve by elimination, where we eliminate one of the variables by adding the 2 equations together. Or we can solve by substitution, where we solve one of the equations for one of the variables and plug it into the other variable. So 3 methods for solving systems of equations.